In A2, we're going to talk about arithmetic sequences and partial sums. So what we'll look at today is to recognize and to write and find the nth term of an arithmetic sequence, to find nth partial sums of arithmetic sequences, and to use arithmetic sequences to model and solve problems. So if you look at your formula sheet, you're going to want to look at the three formulas specifically underneath your arithmetic sequence section of your formula sheet. So remember that an arithmetic sequence is a sequence that has the common difference between each term, which means that you're either adding or subtracting the same number to get to your next term. So if we look at this first example and it says find the common difference and generate the first 5 terms of the sequence. So if our formula for the sequence is 4n plus 3, if we were to find the first term, we would say 4 times 1 plus 3, which would give you 7. The next term would be 4 times 2 plus 3, which would give you 11. If you did the third term, 4 times 3 plus 3 would give you 12. So what we, 12 plus 3 is 15. So what you find is that every time we're adding 4, so our difference would be 4. If we do the same thing with the next sequence, 7 minus 5n, our first term is 7 minus 5 times 1, so our first term would be 2. Our next term would be 7 minus 5 times 2, so we'd be at negative 3. Our third term would be 7 minus 5 times 3, so we'd be negative 8. And what you find is that every term here, we're subtracting 5. So if you look at these formulas and you think about these as equations for lines like mx plus b, where you have the slope, the 4 and the negative 5, that actually is going to tell you, if you're in your explicit formula that's simplified, what the common difference between your terms are. So in this one, we need to find, this is just a continuation. We know that if we look at this as an equation for a line, if we were to simplify this, we would get 1/4 n plus 3/4, where the 1/4 would be in that slope spot. So we know that our difference would be 1/4, and we wouldn't necessarily have to find 3 or 4 terms in order to figure that out. So this is kind of that rule right there, that this formula is your explicit formula for an arithmetic sequence, where D is the common difference between your terms. So here we need to find a formula for the nth term. So if the nth term, that means we're just writing our a sub n equals the first term plus the difference times n minus 1, and then we'll simplify it. Whose common difference is 3, so they tell us that our D is 3, and that our first term is 2. So in order to write our equation, we'll say a sub n equals 2 plus 3 times n minus 1, and we need to simplify and say 2 plus, when we distribute the 3n minus 3, so we get a sub n equals negative 1 plus 3n. So for this next example, again, we're going to write an explicit formula, but this time they give us the information that the fourth term is 20 and that the 13th term is 65. And we want to write the first 13 terms of the sequence. So in order to write all the terms leading up to the 13th term, we have to figure out what the common difference is. So what we're going to do to find the difference is we're going to take the 13th term, our a sub 13, we're going to subtract the fourth term, and then we'll divide by how many terms are in between those. So we have 9 terms between 13 and 4. So we'll say the difference is 65 minus 20, divided by 9, 45 divided by 9 gives us 5. So our common difference is 5. So if we were writing all of the terms, first, second, third, fourth, fifth, sixth, and we could keep going. So we know our fourth term is 20. If our common difference is 5, then we'll be at 25, 30, 35, right? We could keep going to 65. And then we could even go the other direction. So we could go backwards and say 15, 10, and 5. And so we could figure out there, then our first term was actually 5 also. So if we want to find the sum of a finite arithmetic sequence, we're going to use the formula n over 2, where n is the number of terms we're adding. So if we wanted to add the first 4 terms, n would be 4. A sub 1 is your first term, and a sub n is the value of whatever that last term that we're adding. So if we want to find the sum, and we're going to use the formula, we know that our first term is 1. If we count our terms, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our 10th term is 19. So to use our formula to add the 10 terms, we're going to say n over 2, so 10 over 2 times the first term plus the last term. So we would get 5 times 20, which would equal 100. So the sum of all those numbers together is 100. The sum of the first terms, n terms of an infinite sequence, is called a partial sum. It's because you're adding part of the sequence, and we can use it. The nth partial sum of the arithmetic sequence can be found by using the formula for the sum of the finite arithmetic sequence. And remember, that's your s sub n equals your n over 2 times a sub 1 plus a sub n. So in example 7, we're going to look at total sales. It says a small business sells $20,000 worth of sports memorabilia during its first year. The owner of the business has set a goal of increasing annual sales by $15,000 each year for 19 years. Assuming that this goal is met, find the total sales during the first 20 years of business. So this means we want to find the partial sum of the first 20 years. Right? So eventually we want to find s sub 20, which means that we'll do 20 divided by 2. And then we'll have our first year plus whatever the sales were in the 20th year. And so when we look at this, we know a small business owner sells $20,000 in the first year. So we know that our first year is 20,000. And then it increases by 15,000 each year. So we know then also that our D value, the common difference, is 15,000. So what we're going to do is write an explicit formula to find our 20th term. So we'll say a sub 1 is 20,000 plus the difference times n minus 1. And so we get a sub n equals 20,000 plus 15,000 n minus 15,000. Or a sub n equals 5,000 plus 15,000 n. And so if we want to find a sub 20, we could say then that a sub 20 equals 5,000 plus 15,000 times 20. And so we find out that a sub 20 then is 305,000. So if a sub 20 is 305,000. And so then we can go back to our sum, our partial sum. 20 divided by 2 is 10. Our first term is 20,000. Our last term is 305,000. And so if we combine all of that, we find out that after 20 years, the total sales were $3,250,000.